Whoa, with our new friends, we get to solve equations as well. Find all of the solutions of sine of x plus pi over 4 plus sine of x minus pi over 4 equals -1 over this interval. So we're not going to be finding the general solution, are we? We're just going to be looking for how many solutions there are in one unit circle. All right, there's not much to do but expand this. This is going to be sine, cosine, sine, cosine of alpha, beta, beta, alpha, and if it's a plus, sine stays a plus. So I just took care of that first sign. Now, plus, so that plus sign comes there. I'm going to add this one in. So this is going to be sine, cosine, sine, cosine. There's my backbone. Alpha, beta, beta, alpha. Alpha, beta. If it's a minus, this becomes minus. And then we're going to go beta and alpha. And we're saying this is equal to -1. So we're going to solve this. All right. Let's see. I have sine x cosine pi over 4 plus sine x cosine pi over 4 and sine pi over 4 cosine x. So these will cancel and I'll be left with 2 of these. So I can say 2 sine x cosine pi over 4 equals -1. If I had strung these all out in one long line, which you can do, you'd see that these 2 terms will cancel. I have a plus sine pi over 4 cosine x and a minus sine pi over 4 cosine x. And then I have 2 of these, so I just brought the 2 out to the front. All right, let's see. So I'm going to divide both sides by 2, and I'm left with sine x cosine pi over 4 equals -1/2. Now I can evaluate cosine pi over 4. That's root 2 over 2. So I'm going to write this as root 2 over 2 times sine x equals -1/2. I want to get sine x all alone. So I'll multiply by the reciprocal. 2 over root 2 times 2 over root 2. Cancel, cancel. These will cancel. And if I am left with -1 over root 2, if I multiply by root 2 over 2, I get sine x is equal to negative root 2 over root 4 is 2. So that's where I am. At the bottom of this page, I'm at sine x equals negative root 2 over 2. Well, let's go to the top of this page. Sine x equals negative root 2 over 2. On that one unit circle, I do know sine is the y. A, S, T, C. All-Star Tim Curran. All students take calculus. Whatever you like. Sine is positive up. It's the y. It's negative down. So I am going to have an angle in the third quadrant and an angle in the fourth quadrant. Notice for each of these 2 angles, my initial side is that positive x-axis. They're telling me, look, I'm going to go up, and my triangles are always going to involve that x-axis. They're telling me that opposite over hypotenuse is negative root 2 over 2. Or I can just say on the unit circle, they gave me the y. That's why it's so nice to work with that unit circle. So this is root 2 over 2, and this is negative root 2 over 2, which forces our reference angles to be pi over 4. Notice if I have a choice, I go to radians. So here is 4 pi over 4, and here is 8 pi over 4, also known as 1 pi and 2 pi. This angle here is 4 pi over 4 plus 1 more pi over 4 to give us x is equal to 5 of these pi's over 4. We're very happy about that. And this fourth quadrant angle is almost to 8 pi over 4, but back it up, 1 pi over 4. And we're left with 7 pi's over 4. So I get my 2 answers there from 0 to 2 pi. Now, the graphical solution, remember, you could have taken this original equation here and added 1 to both sides. So if I want to do this graphically, the easiest way I can think of is to say, this is sine of x plus pi over 4 plus sine of x minus pi over 4 plus 1 equals 0. Now, I'm making this a function. What happens where y is 0? You guessed it. We're looking at x-intercepts from 0 to 2 pi. So if I go from 0 to 2 pi, my graph looks something like this. And I have, I'm sorry, let's move this 2 pi back to here. So here you can see I've got, graphically, you can see I have two solutions. And those solutions will be 5 pi over 4 and 7 pi over 4. If you don't like my little drawings there, take a look at your book. This is on page 380 of your book. Look at that. There's that same graph showing you could do this graphically as well.